Hello, I'm Kat. Thank you for coming to my talk. I'm a software engineer, and I've dabbled in a few languages over the years. I did a fair amount of Java when I started out. I did a bit of Bash, I did a bit of Ruby, but predominantly I've been a PHP developer for the last 7 or so years. And I still very much enjoy writing PHP till today, but I picked up Go as my second main language about 2 or 3 years ago, and I really enjoyed it. These days, it's actually my main language at work. I no longer do PHP full-time. I work at Monzo Bank, which is a modern bank, and it's written fully in Go. But I'm not here to tell you, just to tell you how awesome Go is, because this is a PHP conference, so it wouldn't be fair. But hopefully, you'll get a good idea of what Go is like from this talk. And what I'm hoping to convince you to do is to convince you that it's worth learning more than one language in general. And I want to show you how this can change you as a programmer and make you a better one, basically based on my experience from switching from PHP to Go. So you might be thinking, what the hell, Kat? PHP solves all my problems. But does it really? Sometimes developers who know only one language will try to do everything in that one language. And sometimes this can cause you unnecessary grief. There might be a better tool out there that would do a better job, but you wouldn't know that if you only know one language or one tool. So just as you wouldn't use a screwdriver to hammer a nail into a wall, maybe you shouldn't try to use PHP for everything under the sun. PHP is kind of like a multi-tool. In fact, sometimes it's famously known as the double-clawed hammer. And it can do a lot of the jobs OK, but it's not ideal. And that's OK, because no language is perfect. But that doesn't mean that you should just stick to the good old hammer for everything. Sometimes you'll just do just fine, but sometimes there might be a better tool out there that will do a better job. So learning a new language is just like adding a new tool to your toolbox. The more tools you have, the more you can do. And you can do things the right way. And it's a really great way to learn new concepts or new ideas for how to solve things in different ways. And then you can also borrow concepts from one language to the other. And maybe you can even improve one language based on what the other language is doing. And we've seen that in PHP over and over again. Many of the tools that we have in PHP have been inspired by Ruby, like Composer. And PHP used to be procedural, and then Java popularized object-oriented programming, and then PHP became object-oriented. So it's worth keeping an eye out for other languages, just to keep up to date with the latest trends. So let's have a look at Go. It's sometimes called Golang, but that's just for Googleability of it. Good luck Googling for Go. But the official name is Go. It's gaining in popularity now, but it's actually 10 years old. It first appeared in November, on the 10th of November 2009. Go 1 was released in March 2012, so that's 7 years ago. And now we're at 1.12 with Go, and Go 2 is also in the works. So Go 2, the main thing that it's going to bring potentially is generics. Go was written at Google by the 3 gentlemen here, Robert Griesmer, Rob Pike, and Ken Thompson. So pretty big names in computer science. Go is a compiled, statically typed language. It's a little bit like C, but with the nice things, like garbage collection and memory management, so you don't have to do it yourself. And one of the main selling points of Go is the built-in concurrency, which we'll, of course, have a look at in a minute. The biggest difference between PHP and Go are, of course, the logos and the derived mascots. It's gophers versus elephants, as you can see here. They come in lots of different shapes and sizes. That's just a small sample of the mascots that I have at home. The width of the gopher and the elephant is the same, but the gophers are about 20 to 25% taller, and the eye size is the biggest differentiator. I'm only kidding. One of the biggest differences is how you run Go apps versus how you run PHP apps. PHP is an interpreted language, so you need a web server with a PHP interpreter on it, or an interpreter on your command line to translate the PHP code into machine code on the fly as you execute your program. Go, on the other hand, is a compiled language, which means you first need to compile it for your chosen architecture, and then you just run it like any other binary. You don't do the translation on the fly. Why is this important? Because it affects the speed. Compiled languages are generally faster than interpreted languages for the obvious reasons that you do the work of interpreting it up front. So you don't need to do this at runtime. So here we have some benchmark for a simple hello world program written in a bunch of languages. So it's Go, Node, and PHP, and HHVM. For comparison, the leftmost column is Nginx, serving a static file. So Nginx is written in C. So you can see that the two columns on the left are compiled languages, and they are the fastest. That's not really a surprise. Node.js is impressively close to Go. Vanilla PHP, which is this one here, is about 2.5 times slower than PHP at under 2K requests per second. Go is doing over 4,500 requests per second. These are just some random benchmarks I found on the internet. They are a little bit out of date because it's from PHP 5.6 and Go 1.4. So both languages got significantly faster in the latest releases. But in general, that's exactly the impression I got when I started doing Go, that it was just a lot faster than PHP. PHP is interpreted and it's built for development speed. Go is compiled and it's built for runtime speed. Although Go also compiles in a second or two, so the compilation doesn't really take that long. Like, it's nothing like Java. So the XKCD meme doesn't apply. So it doesn't really slow you down in development that much. So let's have a look at some Go code. This is a twist on the classic hello world program. So we have a string. Hello, is it something you're looking for? And what we want to do is print out T or me at random. So you can see where this is going. So the syntax is obviously different to PHP. The format of Go code is standard across all Go applications, and I mean all of them on GitHub. So there's just one coding standard for Go, and you just have to stick to it whether you like it or not. There's a tool called Go Format, which automatically formats your code to that standard. So you don't even have to think about it as you program. And honestly, you get used to it very, very quickly. Whether you like it or not, like Go uses tabs, not spaces, but you can do soft tabs. So whether you like this or not, it's your personal choice. But the good side of this is that you don't even have to think about it. You don't have to waste time arguing about tabs versus spaces, or which line does the bracket go on, and so on and so forth. So in Go, we need to declare our package at the top. Packages are a bit like namespaces in PHP or modules in Ruby. And then we need to declare what libraries from the standard package we want to use in our code. Luckily, there is a tool that does this automatically for you called Go Imports, so you don't have to do this by hand. And then we have our main function. So every Go program needs to have the main function. You might have noticed that there is no public or private in front of it. And that's because Go has a simple convention that if the function name or a variable name starts with a capital letter, then it's a bit like public. And if it starts with a lowercase, then it's only visible inside the package. So it's a bit more like private, with the exception of main, which is always lowercase. And this applies to variables or function names. And this is how we declare a variable. Each variable in Go has a type, and you can't type juggle. So this is the long way of declaring a variable. There's also a short way. And Go will automatically work out the type of that variable based on the value that you're giving it. So here we create an array with two strings, me and T, and Go will automatically work out that the type of this variable is an array of two strings. And then say we want to print out 5 of those statements in a row with the random word filled in each time. So we have our for loop, and notice that there are no brackets around the if or the for statement. There are also no semicolons at the end of lines in Go. So there is a little bit of less of visual debt, you could say, compared to PHP. So let's run our program. We get 5 sentences, as expected. So to do that, we used a tool called Go Run, which will take the Go file, compile it, and run it for you, but it won't output the binary for us. Not sure if that's better or worse. It's probably worse. Thank you. So yeah, that's probably OK. So if we wanted to create the binary, we can call go build or go install. And this will output a binary file, as you can see here on the red. And you just run it like any other binary file, or Linux, or Mac OS, or Windows. So if you run it that way, you get the same result. So I mentioned using Go Run and Go Build and Go FMT. And these are just some of the tools that you get with Go right out of the box. This is where I think Go wins over a lot of the languages. Because the easy setup, where you get everything you need to develop and test your application out of the box, is such a great bonus. In PHP, if you want to have unit testing, you need to install PHP unit separately. And if you want to do step debugging or profiling, or if you want code coverage, you need to install Xdebug, which is, again, a separate extension. And then it can be a bit of a faff to set up, and it can just eat up a lot of your time, especially if you're doing this over and over again for every project, like creating the XML files, which pretty much look almost identical for every project. So with Go, you get a formatter, a linter, your unit and performance testing, you get code coverage, you get a doc generator, you get the different compilers, and you even get a race detector out of the box. So once you have Go set up on your machine, then it's good to go for every project. Like, you don't need to install anything extra. Unavoidable pun. So when I first started using those tools, I was like, whoa, that wins. Or Matt Trask said, shit's legit. So one of the things that can trip people up at the beginning with Go is this idea that all your Go code lives on the same place on your disk. At least that's the official way of developing apps in Go. With PHP, you can pretty much put your files anywhere on the disk as long as your server can see them. So you just need to point document root at the right directory. With Go, we have this special environment variable called GOPATH, and that basically points Go, the installation, at the top level directory of where all your Go projects live. And then Go expects then a source directory to be inside of the GOPATH. And then inside the source directory, you can put your projects in the directories. But obviously, you could end up with two projects having the same name. So to prevent a clash, you prefix them with some kind of unique vendor name. So very often, and that's pretty much the standard, you use your GitHub or GitLab URL as the vendor prefix. So here in the example, I have two projects. One of them is on GitLab, one of them is on GitHub. And they all live under the same GoPath directory, which is the blue bit at the beginning. Some people like it. Some people absolutely hate it and find different workarounds around it. I personally don't mind, because for the first time in ages, it forced me to organize my projects on disk really neatly, and now I can find all of them because I know where they all live. So I no longer have to search for hours for, like, where did I put that project? So I personally don't mind, and again, you get used to this pretty quickly. However, GoPath is going away, actually. There is a new thing coming into Go called Go modules. It's enabled as an experimental thing in 1.11, or from 1.11, and it will be on by default from the next release, which is 1.13. And Go modules are a lot like Composer, except for they're an even tighter integration into your workflow. So imagine if your PHP command would also run Composer install for you if it detects that there is a composer.json file. And that's essentially what modules do for you. If there is a Go modules file, it will pull down the dependencies as part of your run or build or install. So that comes in from 1.11 onwards. Gets rid of the GoPath, essentially. It lifts up that restriction, so you will be able to put your files anywhere on disk. And it actually brings proper dependency management and package management into Go, which is something that Go didn't have forever. There are a lot of quirks under the hood, but the principle of how modules work is fairly similar to Composer. So there is a sumcheck file, which is the equivalent of the log file, and then Go modules will actually download the dependencies from authenticated mirrors, so also sort of increase the security a little bit. It hinges on Semver. It requires everyone to use Semver correctly, because it will try to bring you up automatically if it's safe to do so. So if it's just a sort of patch number or the bug fix number, it will try and upgrade you on the fly, so you don't have to do it yourself. The good news is that you can auto-import your existing sort of package management files into modules really easily. I think it supports something like 9 existing package managers and converts those files into the modules file. So GoDep is one of the most popular ones, so you can easily convert into modules. So what kind of apps can you build with Go? I tend to think of Go as a box of Legos that you're given. So you can, in theory, you can build all sorts of cool things with it, but you kind of have to figure out a lot of it yourself. PHP, I think, is a bit more like the ready-made sets, where a lot of the thinking has been done for you already, but on the other hand, and you sort of get a nice instruction leaflet, but on the other hand, you're a little bit more limited as to what you can build. Both languages are great for web apps. They're great for APIs. You can use Go or PHP to write command line apps too, or like Bash scripts. PHP, I think, excels at the web app level, whereas Go you can also build some lower level things like proxies, reverse proxies, load balancers, servers, all those infrastructure components. Basically, anything that doesn't need a UI and needs to be fast is a good candidate for Go. So let's move on to the reason why so many people start looking at Go, and that is the built-in concurrency. As a PHP developer, you rarely, or in my case, almost never, come across this in PHP land. You can use a PHP extension called pthreads, or there are frameworks like React PHP or AMP. I haven't tried any of them. I haven't heard of a single person. I've heard of one person that used pthreads in production, and that thing has been around for years and years and years and years. So it's not really wildly used. So I don't really know how good these are. Most PHP implementations tend to be single-thread based, so it's just less common to come across concurrent patterns in PHP. Go, it has been designed with concurrency in mind from scratch, so it's also been optimized for that. In PHP, it's kind of been added on with the frameworks, so while it can still probably work well, it will almost definitely be slower than Go because you're using a framework on top of PHP. So it wasn't until I started doing Go that I started to think about what is concurrency and what does it mean for my program to run concurrently and to run, or is concurrency and parallelism the same thing? Do they mean the same things? Turns out it's not the same thing. So concurrency is when a situation where at least two threads in theory can make progress in your app. And parallelism is when at least two threads are executing at the same time. So you can have a concurrent design in your program, but where, in theory, multiple threads can make progress at the same time. But unless they're actually running at the same time, you only have concurrency. You don't have the parallelism. So it depends on things like the number of cores your machine has, for example. If you have one core, then you're most likely either going to just go single-threaded, so you might have concurrency but not parallelism, or you might go into virtual parallelism, so that's your machine essentially pretending that it runs things in parallel, but it just slots the different threads onto a single core really quickly. But if you have many cores, like 4, you can actually have physical threads running on every core, so you have authentic parallelism in your application. So just to illustrate, let me show you a silly example. This is taken from an excellent talk by Rob Pike, or with the same title, Concurrency is Not Parallelism. And he's one of the authors of Go. So I highly recommend to watch it. I've got a link to it later. It's only 20 minutes long. But it goes into a lot more detail into what the two things mean. So in this silly example, we have a bunch of gophers running around and burning books. So we have 2 sets of 4 gophers, and each one of them has a specific role. So one of them is loading the books onto the trolley, one of them is taking them to the incinerator, one of them is burning them, and the fourth one is just taking the empty trolley back. So this is, in theory, a concurrent design because we can, in theory, have all 4 gophers running around at the same time doing their job. So that's assuming a world where they're perfectly synchronized and every single one of those jobs doesn't block any other jobs. And moreover, we can add more sets of those 4 gophers, so we can scale that book burning business up as much as we want to. So we have concurrency here, and if at least 2 gophers are running at the same time, we also have parallelism. But if only one of those 8 gophers is moving at one time, then the design is still concurrent, but we don't have parallelism. So we talk about concurrency in Go in general because it's just a generalized form of parallelism. So it is worth keeping in mind that even if you make your program concurrent, it's not guaranteed that it will actually run in parallel. So that's why it's important to be aware of that distinction. It's a subtle difference, but I thought it was interesting and worth mentioning because it's not one of those things that you come across in PHP. So one of the most appealing things about Go is how easy it makes to write concurrent programs. Basically, it boils down to 3 words: the built-in Go keyword, goroutines, and channels. A goroutine is not exactly a separate process. It's not an OS process. It's officially defined as a lightweight thread of execution, which is managed by the Go runtime and then mapped onto your OS threads. Goroutines all run in the same address space, so they all access shared memory. So you have to be very careful about synchronizing access to that memory and making sure they don't override each other. And here is how we create goroutines. We just put the Go keyword in front of whatever function we want to call, and it's that simple. So this function will now be executed in a separate goroutine. or a separate thread of execution. So here's another example. Say we want to print out hello world, but we want hello to be printed out 5 times by the main thread and world to be also printed out 5 times, but by a separate Go routine. So this is just the simplest example of how we can use Go routines. So we define our function called say as normal, and that just takes in a word, and it will print out the given word 5 times. And in the main function, we call this function twice. So once for hello and once for world. But on the first line, we put the Go keyword in front of the function call. So that will make Go execute this function in a separate Go routine. And this is non-blocking, which means that as soon as the first line gets executed, the main thread will move on to the next line. It won't wait for the Go routine to finish. So they will be running at the same time. And here's the output. We get both words printed out in random order by each of the Go routines. And if we run this program multiple times, we'll get a slightly different output each time. And that's because those 2 threads are running concurrently, so without any deliberate synchronization, the output will be completely random. An interesting case is here, where I've highlighted it. In the third column, world was printed last, and world is printed out by the Go routine, which means that the main Go routine has terminated, and then the Go routine still kept running. And it didn't wait, so the main thread finished without waiting for the Go routine to finish. And that's not ideal, because you can end up this way with zombie Go routines that then you can't sort of control anymore because your main thread exited. And that's not ideal, so that's something that you should try and avoid in your Go programs. So to make sure that we don't exit until Go routines are done, then we can use something called the sync group. So we declare the sync group at the top, and then we add one for the Go routine that we're going to kick off. So you add one for every Go routine that you know you're going to have in your program. So then we kick off our function, and then Go also supports anonymous functions or closures. So this is just an example of that. And in there, we use a special defer keyword to make sure that we call done on the sync group before we exit the function, the closure. So defer is a little bit like finally in PHP. It's guaranteed to be executed at the end of the function. So it's handy for things that we always want to make sure that we do at the end of the function. So close any file handles. You can put the defer right after opening a file to make sure that you don't forget to close it. Releasing the mutexes, or telling the wait groups that you're done. And then you call say, just like we did before. And then we call say from the main Go routine. But then we tell the main Go routine to wait by calling wait on the sync group, on the wait group. And when the wait group receives as many dones as the numbers of ones that we've added, then it will stop waiting and it will allow the main thread to move on. So this means that even if the main Go routine is done printing hello, it will wait until the other Go routine calls done in the defer, and then it will print out done itself, and then it will exit. So that little example just shows you that analyzing concurrent programs is a little bit more involved, perhaps, than PHP programs. And it could be a little tricky, because some things might be deliberately happening at random, and some things are expected to be very tightly synchronized, or expected to happen sequentially even. There are other constructs, like mutexes that I mentioned, for synchronizing access to memory. So like I mentioned before, because we are all running in the same address space, you need to make sure that we control access to the same address space. But luckily, a lot of the native Go functionality, like all the functions from the standard library, they're all concurrent safe, and safe for concurrent use. So you don't usually have to think too much about it. And it's pretty easy to use the standard library functions. It's not as complicated as it might sound. And Go, like I mentioned before, even has a built-in race detector to help you analyze and detect any problems. An even better way to provide some synchronization in Go programs is to use this thing called channels. You can think of channels as pipes or queues, where you can put values into the queue, or you can take them out of the queue. And if you share this queue or channel between 2 Go routines, then you can send and receive messages between those 2 Go routines. So channels in Go are first-class citizens. They are type, so every channel has to have all the values on the channel have to be of the same type that is declared for the channel. And channels can also be bidirectional, or read-only, or write-only. By default, sending and receiving data on a channel is a blocking operation. So that means that if a Go routine is waiting to receive something from a channel, or waiting to send some data on a channel, it will wait until something is ready to be sent or received. And that is key, because that gives you the ability to control the flow in your program. Because it allows us to synchronize the goroutines without using any explicit locks or wait groups or any complicated conditionals. So we can declare channels just like we declare variables in Go. So here I have a variable called messenger, which is a channel of strings. And before I can use this channel to send messages onto it, I need to actually create it, not just declare it. So to do that, we use the special make keyword. The make command also takes an optional second parameter where you can specify the size of the channel. So channels can be buffered or unbuffered. And then if we wanted to send some data on the channel, we point the arrow, which is a special operator in Go, at the channel to the left, and we provide the value on the right. And then if you want to receive data from the channel, you do the opposite. You can also assign it to a variable on the same line. So you do the opposite. You point the arrow away from the channel. So the general rule when reading Go code with channels is that the data flows in the direction of the arrow. This is how you might implement a typical pattern used in concurrent programs, which is the worker pool. So a worker pool is essentially a pattern where instead of having one thread execute every incoming task in a sequence, you can create multiple worker Go routines and have them wait for any incoming tasks to be processed all concurrently. So that means that you can speed things up and you can process things a lot quicker, depending on how many workers you have. So if you have 3 or 5 workers in your pool, you can do things potentially 3 or 5 times faster than if you had a single thread. So at the top, we create our channel of tasks. So assume task is just some struct that I declared. So task is the type of the channel. And we call it jobs. And then at the bottom, we use the special range operator in Go to iterate over the jobs channel and take the tasks of that channel as they come in. So then we decide how many workers we want to have created. So say that we have some limit variable that defined there. So we will create that many workers, and for each one of them, we'll kick off the function in a separate Go routine. So now every worker will be a separate Go routine running at the same time. So we use the same range operator again inside the function to listen on the jobs channel, and then as soon as a task is available, we take a task off the jobs channel, and then we call some do function on it to do something with it. And then at the bottom, assuming we have a variable called work slice, which is just some kind of array of jobs to be processed, we put those jobs one by one onto the jobs channel, and then as soon as the first task becomes available on the channel, whichever one of the Go routines, like let's say we have 5 Go routines, it could be either one of those 5 Go routines that picks it up. So the order in which they will be picking up the tasks is not defined. It's completely random, but that's kind of okay in this case. We don't really care about which one picks up which job. So hopefully that kind of gives you an idea that concurrent designs like this allow us to process things much faster. And for me, just the ease of picking it up and looking more into concurrent and event-driven designs, it was one of the reasons why I enjoyed learning Go so much. You can obviously try out the frameworks in PHP, but I think using a language that just outright promotes concurrency to you and makes it so much easier to use, it just makes it a bit easier to pick up. So my intention wasn't really to tell you that Go is better than PHP or that PHP is better than Go. They're just different, and you should think about what you want to build first, and then which language will help you solve that problem in the most efficient or the easiest or the simplest way or the most elegant way. Generally, I think in this day and age, we need to be getting smarter as programmers, and we need to find ways to optimize our processing with the ever-increasing loads on our system. And given that our hardware is no longer getting the 50% boost of efficiency every 18 months, at the moment, it's more like 22% every year. So Moore's law doesn't really apply anymore to hardware. So exploring languages like this gives you the benefit of discovering all the different ways and all the different patterns of making your programs faster, like event-driven designs or concurrent processing. I genuinely think that as we're reaching the limits of hardware and language optimizations, the focus will shift. It will start shifting to making our programs concurrent. And you see signs of that popping on Twitter. Somebody tweeted about running tests in parallel, and we're now experimenting with that for the PHP project. And it's that shift in thinking from doing things sequentially by default to doing things in parallel by default that is key here. And we should all be defaulting these days and age to running things in parallel if we can. There is also a framework that came out a while ago called SWOOL, which is officially the name is Production Grade Async Programming Framework for PHP. Quite a mouthful. And that just feels like writing Go in PHP. It has the exact same terminology. It has channels, coroutines. It has exactly the same concepts. So it feels like just writing Go in PHP. And then we're also looking at just-in-time compilation in PHP 8 to try and make more and more of PHP compiled. So that also is kind of trying to take some of that interpretation away from the runtime. Obviously, I ended up comparing the two languages quite a lot as I was going along, and here are some of my favorites about each. I think that PHP still is, at least for me, it's great at bashing something out really quickly, especially if it's not a concurrent program, if it's not that important that it runs fast. If it's simple and sequential, I can probably do it in PHP without thinking about it too much. I like that PHP has a lot of mature, well-established frameworks and libraries to choose from. It's pretty widespread, so there are tons of tutorials and documentation online. Like PHP has been around for over 20 years, so that's not surprising that there is a lot more material available. And I think PHP 7 was really a huge leap forward to bring PHP back into the game. It's faster, it feels modern, and I love the ability to enforce types as well. But there are quite a lot of things that I liked about Go as well. I do love the strong types from the start. It just feels safer and less prone to errors or surprises along the way. I've never been a fan of type juggling. What's new, there is a thing called the idiomatic Go, and that's essentially a list of rules that all Go programmers use to really encourage you to keep things simple and to follow object calisthenics. So that's a really big part of Go. I love the error checking policy in Go, and I'll come back to that in a minute. I love that Go has multiple return values. I think it's a huge convenience, and it feels a lot more natural when you're writing your programs. And by multiple return values, I mean you can return more than one value from a function, rather than like return different types of an argument. So you can return a value and an error, for example. I love the built-in concurrency. It's really fun to play around with. I love the tooling. I love that everything is built in. You just need to install Go once, and you have it all. Go is super easy to set up and run. Go is available from all the usual things like brew and like Mac packages and all of that stuff. So installation is super easy. And I like the wider application, the wider sort of set of applications that is possible with Go. So not just web apps, but also the infrastructure components. And I'm really, really impressed by the speed and how much faster your programs can be if you rewrite them with Go. And I think that's always going to be the case because it's a compiled language. At my previous job, we had a PHP program which was just taking off emails from an email server and processing them in parallel. And at some point, that sort of PHP script was running with a backlog of about 5,000 emails at any given time because it was just so slow at processing them. So we then took it and rewrote it in Go, and we used the worker pull pattern. So we had 5 goroutines processing incoming emails instead. And because every email is independent, you can actually do it all in parallel. Like it's not like one email that needs to wait for another email to wait to finish being processed. And we went down from the backlog of 5,000 emails to pretty much no backlog ever again, and the whole thing running in 2 seconds and dealing with all the emails. So it really can help you out if you're like reaching the limits in PHP. This talk obviously wouldn't be complete without briefly mentioning the communities surrounding both languages. They are very different in many ways, but they're equally great. And this talk is kind of proof that you don't need to limit yourself to just one thing, or one language, or one community. The PHP community rocks, and we obviously have so many great conferences and meetups. I think this is James and Jeremy at PHP Bulgaria a couple of years ago. But Go is quickly catching up. The first GopherCon, so Go conferences are usually called GopherCon, that was in Denver 5 years ago, so quite a while ago. And since then, we've had Go conferences pop up literally all over the world. So there was GopherCon EU in Tenerife just now. There was .go in France. There's GopherCon Brazil, India. There's Gotham Go in New York City. There's something called the Gopherpalooza in San Francisco, and many, many more. And then if you ever heard of the PHP UK conference, the organizers of that conference, they started a GopherCon UK conference, or it was called Golang UK a few years ago. And that is in London in August every year now. And I also co-organize a London Gophers meetup in London. Before then, until very recently, I was co-organizing the PHP Southwest meetup in Bristol. And being part of both communities and both meetups was really awesome because I could bring lots of ideas across, not just from the languages itself, but also when it comes to things like organizing meetups, you just borrow ideas from one to the other and apply it across. Some of my not so favorite things about each of the languages, or what I think could be better about each. PHP, as opposed to Go, feels a lot more inconsistent. We've all probably heard of the fractal of the bad design article. It kind of allows you to do stupid things sometimes and get away with it. It lets you leave dead code around, which Go doesn't let you do. Like Go will physically not compile if you have dead code. I think that PHP, after I got used to Go and like the lack of brackets and the lack of semicolons and all of that stuff, and the public-private and all of that, it feels a little bit more verbose for me right now. And I really, really wish for multiple return values sometimes. Go, on the other hand, is sometimes a bit lacking in mature, well-established frameworks, like the go-to things that you do for a language. There are a few of those, but they're not as established as we have in PHP. And that's kind of expected because obviously Go is much younger. So there is a little bit more uncertainty in Go because we're just discovering new ways of doing things. Obviously, concurrent programming it could be new to you, but it's also exciting because it brings lots of fresh ideas. Dependency managers is my biggest pain point with Go. We had to wait pretty much until now to get a proper one, and it's still fully not bedded in. So that was a bumpy ride in the Go community for a few years. And like another thing that I catch myself saying sometimes with Go is like, do I really have to do it myself? And that is like a big difference between PHP and Go. In PHP, you just have a lot of built-in functions and like a lot of sugar built into the language, whereas Go feels a little bit more raw. And the set of functions is deliberately kept small to keep the language simple. But that means that sometimes you have to do a lot of the functions yourself, or a lot of the processing yourself, or just write the sugar yourself. You don't get it out of the box. An interesting observation for me was noticing some things that I started doing differently in PHP after spending a few years in Goland. I think as a result, I'm now way more mindful of keeping things simple and clean, even if the language isn't forcing me to. And I also became way more strict with types, even before we had types in PHP. So like I said, I never liked type juggling. I never really relied on it. But now I'm making it explicit in PHP. Like from 7, we can actually declare and force people to use strict types, at least for scalar and return types. And yeah, I'm really looking forward to 7.4 bringing in typed class properties as well, because that kind of completes the circle. I also tend to use shorter and more sensible names now. For example, if I have a class that sits in the controller's namespace, do I really need to call this class a controller as well? It's kind of obvious, like if it sits in the controller's namespace, it's a controller. And I certainly tend to avoid the enterprise style naming, like in this example, public static listenable future chain of listenable future and a function which extends listenable future, which extends a function, and dear God, make it stop. That's a great example from another one of Rob's talks called public static void, where he talks about why he was so keen to make Go simple and keep it simple. So error handling. Imagine that we're validating a name. The thing is, on the left is what I used to do before I started doing Go. And I can't even tell you easily what's going on in there. There's like some if, and then if not that, then else, and it's kind of a mess. But the code on the right does exactly the same thing, and it's so much easier to understand. And the difference is that you handle the errors as soon as they happen. So as soon as something doesn't meet one requirement, you just return false. You don't carry on. So you don't run into a risk of doing something you wouldn't want to do if there are errors, and if you forget to catch it soon enough. So I prefer this fail fast approach, and that is the standard in Go, and that definitely changed my thinking. It also gives you the benefit of sticking to the 2 lines of sight that you can follow as you read the code. So the idea is that another programmer, including your future self in a few months, can glance down a single column and understand the expected flow of the code without having to nest in and out quite a lot, because that just adds to your overhead, to the overhead in your head. So you just avoid sort of like that jumping around between the different conditions. So we have 3 lines of sight on the left, only 2 on the right. I think it's much easier to read. Of course, this is not invented by Go. This is something called the object calisthenics, and it's been around forever. I highly recommend reading up on it if you have never heard of it. I think Raphael is the calisthenics guy in the PHP community, and he has a really good blog post explaining those. So I think it's just a good advice in general, but it was Go that made me apply it a lot more. Using interfaces. If you design your domain well and you leverage the power of interfaces, and if you use interface segregation, then obviously your code is much safer to change, it's much easier to understand. And this is actually how I got into DDD and the hex architecture. It was through the super easy implicit use of interfaces in Go. So Go's implicit interfaces are slightly different to PHP or like any inheritance-based language where we think of something as being an instance of X rather than having the properties of X. So in Go, the focus tends to be on the have, and which functions does your struct have which satisfies a given interface. So if a struct has methods A, B, and C, then it implements interface X. And if an object is of type X, then it's guaranteed to have functions A, B, and C. And you don't declare that explicitly. Go works out what struct implements what interface behind the scenes and like sort of under the hood. So you don't actually need to declare it explicitly anywhere. So if we define a shape interface in Go, which just has one area function, then we declare a struct called circle, which then implements the area function, then Go knows that circle implements the shape interface, and you don't have to declare it anywhere. In PHP, obviously, you have to declare it explicitly and say that it implements shape. So this just makes refactoring a little bit easier and a little bit faster because you don't need to update all the references. And how do you know that the interfaces are all OK? Well, your program just won't compile if the interfaces are not right. So that's the simple feedback that you have with Go. So I think that learning Go has definitely made me a better PHP programmer. I think knowing more than one language gives you more than one worldview, and you can share ideas across languages. It goes without saying that you're more employable. These days and age, like everyone's looking for developers that can do more than just one language. And it just feels great to have another tool under your belt. So I encourage you to go out and learn whatever programming language you wanted to look into next. It doesn't have to be Go. If you did want to try out Go, here are some recommendations from me for where to start. The Golang.org website really has it all. There is a blog where they go into a lot more detail into some of the decisions that were made for the language. It's just sometimes a really deep down into some of the functions that they've written. There is something called the Tour of Go, which is the nice, easy introduction into it. There's also something called the Go Playground, which is really, really cool, and it lets you try out Go code in your browser without having to install anything. And the cool thing about it is that the playground is also integrated with the Go docs. So as you're reading through the docs, you can actually go in and run a given function, and you can tweak some parameters on the fly, which is really cool. And I kind of wish PHP docs had that you can just look at the function and actually try it out. And I also put links to some of my favorite talks that I watched as I was learning Go. Concurrency is not parallelism is the one that I mentioned earlier. And simplicity is not complicated is another one. They're both by Rob Pike. And then those of you who are into containers, like Docker-like containers, Liz Rice, who's one of the well-known people in the Go community, she did a really cool demo of building a simple container in Go in 20 minutes on stage. And she also really did a really cool demo of writing a Go debugger from scratch in 20 minutes. So those are the two talks. They're really cool to watch. It really gives you a good idea of what containers actually are and how they work. The slides should be online already. I've tweeted, and I put a link to them on the joined in page, so you can have a look at that later. So please, if you have any feedback, please give it on joined in. Like I said, the links should have gone out already. If you have any questions, I think we have 3 minutes left. I'm also going to be around, so feel free to come along and ask anything, or tweet me. My Twitter is up there. And before I finish, I was asked to remind you all that there is now an Italian ice cream after this talk, before the main keynote. So go and have some ice cream. Thank you. Are there any questions? Yep.
Yeah, you mentioned error handling.
Yeah, so I'm just going to repeat the question for the video. So the question was an observation that in Go you don't have exception handling or throwing exceptions, and you have to check the return value every time. So the answer to that is that in Go there is a simple convention that because you have multiple return values, the last thing is an error, and it's either a value or a nil. So you very quickly get into the habit of running a function and first of all checking if the error is not nil. If the error is not nil, you deal with that and you do something and you just return right away, which goes back to the 2 lines of sight thing. And if the error is nil, then you carry on as normal. So you kind of don't need exceptions because you deal with the errors as soon as they happen. And it's just like a slight mind shift, but I wouldn't say it's worse or it gives you any disadvantage. I actually didn't like quite often the fact that my exceptions in PHP can bubble up and I'm not actually sure when they're going to be caught, or like, are they going to be caught in time before this is executed or afterwards? You have to kind of go back and check yourself, where is the thing that catches your error, your exception. Whereas in Go, you just have it right there. You're like, okay, if this is not nil, I can either explicitly carry on if it's fine, or I just return, but because there's no point doing anything else because, reading from a database didn't work, therefore, it doesn't make sense to do anything else. So it's just a change of thinking. And I think it's just simpler because errors are first-class citizens. So error is a type in Go, just like string or Boolean. So you can actually distinguish, even though it's the same type, you can compare errors and you can work out which one of the errors it is. Because you can define them as constants and you can say like the error for something not found is this error, the error for something, I don't know, missing is another error. So you can actually work out what's wrong with the error. So yeah.
I suppose that I'm used to the code or the function itself raising an error if something wrong happened, instead of recalling the function having to check if there was an error.
Yeah, I mean you can throw errors in, you can return errors in Go as well.
I guess.
Yeah. It's kind of like, it forces you to just stick to the few simple concepts, but you can do a surprising, like they are surprisingly powerful, even though it sounds like it's not really, it just simplifies a lot. You basically don't have like try or catches or anything like that. Yeah. Any other questions? Yes.
So you mentioned about those channels that by default they're not blocked by receiver.
They are blocked by
yes,
default.
Exactly.
Yeah.
So you can, but would you ever see any use case to not do that, or would that just become too confusing?
Not really. So I haven't come across a case where you want them to be non-blocking. Most of the time, like it doesn't actually block, because if something can easily read a value out or put it in, then like it would just immediately get executed. But where it comes really handy is kind of making sure that you wait until something becomes available and that kind of thing. So rather than the kind of, so for example, instead of doing the wait group, where you just add one for every Go routine and then you like wait until they all call done on itself, you could, for example, have a channel between the main thread and every single one of the Go routines, and then you just listen on the channel, and as soon as you get 5 values back, you know that they've all finished, because...
So it doesn't really make sense to not block based on that, right? Because then kind of defeats the purpose.
I mean, it makes sense, because then you block the main Go routine from exiting, because it has to wait until it got 5 values back, and it can keep track of how many it received. So like in Go, I think basically... the saying is that you communicate not by sharing memory, but by the channels. So like you kind of avoid touching the memory directly, and like things like counters and that kind of thing. Yeah, you kind of go, if I establish a channel between my main thread and the 5 Go routines, and the last thing they do is put something back on the channel, then I know that until I've got 5 values back, I shouldn't be exiting. So yeah. Anyone else? No, I think we're good. Thank you.